We're going to talk about the properties of ionic bonds or ionic compounds versus the properties of covalent bonds or covalent compounds. So we know ionic compounds, we're going to call them formula units because ionic compounds are actually a ratio of ions, ions being charged particles held together in a crystal structure. So they're not actually like individual, like you can't have, like if you have a salt molecule or salt compound, for example, you can't have just one Na and one Cl. It's actually going to be a ratio of Na plus ions and Cl minus ions. We're going to call those structures ionic crystals or lattice crystals. And we're going to call one unit, we're going to call that a formula unit. So if you've seen that in class, that's what that means. It's just a ratio, the lowest ratio of ions. Okay, so ionic compounds are composed of metals, which are cations or positively charged particles, and nonmetals, which are anions and negatively charged particles. And that they're held together, they actually create what we call salts. So anytime you hear the word salt, it's not necessarily table salt. It can be any type of ionic compound. All right, so ionic compounds, when they're held together, they actually form something very rigid. This is an example of ionic compound. It is noticed that they're rigid, it's hard, it's very hard and brittle to the touch, and they're very sharp. So ionic compounds can actually can hurt you, and if you rub around in your hand, they actually have this hard kind of pointy feeling to it. Okay. Also, their melting points and boiling points are really, really high because basically all they are two ions held together. For example, table salt has a melting point of 801 degrees Celsius, like it's ridiculously high. You've never actually melted salt before. It's just too much heat is required, too much energy is required to break apart those ions to make it melt or to make it actually like a gaseous compound. The energy that it takes is actually broken down into Coulomb's law. Coulomb's law explains that mathematically. So the force that's held together, that's the F. This is our constant, which is the Coulomb's constant. And then these two represent the charges multiplied together divided by the radius of the two ions squared. So the bigger the compound and the smaller the ratio, or the smaller the charges, the actual easier it is for it to break apart and melt. So, for example, if you're comparing cesium bromide versus calcium oxide, cesium bromide has let me make this darker, +1, -1 charge. So these guys have very low charges multiplied together, and these guys are big ions, they're pretty big. So that's going to take not much energy for them to break apart. However, calcium is a +2, oxygen's a -2, and they're smaller in comparison, so they actually have a much higher, they're much more, the force that's holding them together is much greater. So they're actually not going to, it's going to take a lot of energy to melt that one. If we compare it to covalent compounds, we're going to call them molecules, they're actually soft and round. So if we were to look at a picture of a covalent compound, this is sugar, notice it has softer edges, it's much more smooth to the touch, there's no hard spots or pointy spots that you can actually it's very soft, it's very, so it's much more smooth comparatively. So when covalent compounds come together, we're going to call those things molecules. They're different because you can actually have one molecule in your hand versus ionic compounds, you can't. So they're composed of two or more nonmetals. So nonmetals only, they are not ions at all. They're actually, the reason they're called covalent because they're sharing their valence electron, covalent. They're sharing their valence electrons together. They're not exchanging them as they are in ionic compounds. Their melting point and boiling point are relatively low comparatively also because, so for example, sugar, which we saw, is only 186 degrees Celsius to melt. I'm sure you've melted sugar before. You've melted it for caramel and things like that. It's really easy to do in your kitchen as compared to salt, which is literally impossible to do. So the reason their melting point and boiling point is really based on their intermolecular forces, how tightly they're actually bound together to each other. And this is actually a whole other topic all amongst itself, which we can get into. So one last thing, solubility, meaning how well they dissolve in water, or how well they dissolve in water. So both ionic compounds and covalent compounds pretty much can dissolve in water depending on what actual compounds they are. But when you dissolve salt in water, it breaks up into its ions. This is what we call an electrolyte. They actually can create electricity. Sugar molecules or covalent compounds, when they're put in water, they also dissolve, as you probably know when you make tea or whatever. They'll dissolve too, but they don't break up. They just break up into their molecules. They don't actually break up into their individual atoms as ionic compounds do. So those are the main differences, really, between ionic compounds and covalent compounds.